Now, come on, let us start the class. Where we stopped in the last class, it is rock cycle. Meaning what? We have completed the first unit of geomorphology, which is a very simple and a small topic called as rocks. With this, we came to know that how to go through the topics and what is the connectivity you need to maintain and all these things. Now, let us give the major topic heading as the Earth's interior. Give the heading as the interior of the Earth or Earth's interior. Earth's interior. What is there in the Earth's interior? Am I audible all? Everyone? Now, what is there in the Earth's interior? Rock, sir, rock. Entire when the terrestrial planet, the planet is called as the terrestrial planet. What should be there in the Earth's interior? It is a rock. But how those rocks are arranged? Now, let us introduce the Earth in a different way. Let us introduce to the Earth in a different way. Like, suppose if this is the Earth, this is where we are staying, right? This is how we are staying. Let us imagine the guy who is staying here. How is he staying? He's staying like this, okay? Don't think that all we people are straight like. In fact, we are in India, how we people are. We are like this. Got the point? Now, man with his great innovative capacity, man with his great knowledge, what he did, he himself traveled in the space for about almost some lakhs of kilometers to the moon. Also, he has sent certain rovers. What is a rover? Rover is nothing but a robot. Rover is nothing but a robot. He sends certain rovers, certain instruments beyond Neptune. Even today, this particular rover is going beyond Neptune. And it's not that it's only simply moving. It is having the contact with the ground station. It is taking the picture and it is sending to the ground station. What is the name of the rover? It's called as Voyager 1. It's called as the Voyager 1. Even today, it is moving beyond the Neptune. And in fact, because of the Voyager 1 only, we came to know about the characteristics of the Oort cloud. Where it is right now, it is passing through the Oort cloud. What is this Oort cloud? The cloud that is present beyond the Neptune, beyond the Kuiper belt. That is what the Oort cloud. It is giving the very great information regarding the Oort cloud. Like, there are certain magnetic properties that are present there. When the rover is going, its path is being deviated. Someone is pulling towards the other object. These are the things that are happening. And therefore, it is giving each and every information to the ground station. Meaning what? See the knowledge of the man. He has sent the instruments beyond Neptune. Even beyond the solar system, he can send the instruments. But what is the very ironic thing is, what is there under his foot, he doesn't have the direct information. What is there under his foot, he doesn't have the direct information. What do you mean by direct information? He can see through the telescopes directly the moon, other planets, and can get the first hand information. How do you know that there is a planet called as Jupiter? Because we are seeing. The moment once we see, yes, we can believe. But what is a very ironic condition is, we don't have enough knowledge about what is there under our feet. We are staying on the surface, but what type of material is there under the lower layers, we don't have a very good clarity. That is what the ironic condition that is present with us. We are moving to different parts of the region, but what is not there is the information regarding the Earth's interior. Though the direct information is not there, we are having certain indirect evidences. With that indirect evidences, the scientific community started understanding, analyzing, inferring the Earth's interior. What is the knowledge we are having right now regarding the Earth's interior? It's all about the interpretation. It's all about inference. It's all about, it might be present like this. Probably this may be the condition. This is what the information we are having regarding the Earth's interior. Do anyone directly have checked the material directly? No. Why? Because whenever you are seeing the surface, this may be the surface where we are staying here. As and when you go to the deep inner layers, the temperature as well as the pressure is keep on increasing. Whenever it is increasing, the man tried to dig the land. But he could able to dig only for a maximum of 3 to 5 kilometers. Beyond 6 kilometers, he is unable to go. The moment he is going beyond 6 kilometers, what is happening? The pressure was so high, the blood was coming out of his body. Through all the possible ways, the blood is coming out. So he is unable to go. Forget about he himself going. Let us send certain cameras. Let us send certain instruments. Therefore, he started digging where? Not on the surface, in the oceans. Because already it is 6 kilometers of depth in the Pacific Ocean. If you can dig right from there, then you can go further deep. Then they started their luck under the program called as Deep Ocean Drillings. Deep Ocean Drillings. The mission is called as the Deep Ocean Drilling Mission. When the people started going for drilling, not one country, all the geologists of all the countries clubbed together, they started drilling. Then they came to know that we can't drill beyond 12 kilometers. We can't drill beyond 12 kilometers of depth. Even though if the instruments are made so strong and the instruments are penetrated deep in the inner layers, they are getting melted up. That is what the condition. Because of such a great temperature, such a great pressure, man is unable to send the instruments beyond 12 kilometers. There is a place called as Kola Peninsula. There is a place called as Kola Peninsula in the Arctic Circle. In the Arctic Circle, meaning what? Suppose if this is the globe, this is Russia, right? This is the place called as Kola Peninsula. You can check even in the atlas. That is called as the Kola Peninsula. In the Kola Peninsula, the deep ocean drilling project was done, and this is a highly successful project where the man could send the pipelines up to a depth of 12 kilometers. This is the achievement man did till time regarding the Earth's interior. But what is the depth of the center of the Earth? Almost all 6,400 kilometers. Up to what depth we entered? So we are having some knowledge regarding the Earth's interior only up to 12 kilometers. Beyond 12 kilometers, what is there? We don't have a direct information, but we do have certain indirect informations, indirect evidences, indirect sources. Because of this one, we can interpret. Can we say exactly this one? No. What we can do is, we can infer. We can interpret, we can infer, we can analyze. We may feel like, yes, this might be there. Probably it can be there. That is what the knowledge we are having right now. With this knowledge, let us discuss the Earth's interior into two parts. We need to know what is the information given by the scientist, which is called as the factual part. Let us call this part as a factual part. What do you mean by factual part? What type of structure is given by the geologist? All the world geologists met at one place and started, because one geologist having some information, another geologist is having some other information. All the information was being clubbed together and it was given as a consensus. What do you mean by consensus? Agreed and accepted condition, where all the people came to a meeting and they came to know that, yes, if at all I am contributing this idea, I am contributing this idea. Finally, they came to know that, yes, the earth interior should be like this. This is what the consensus they came to. Is it clear? That is what we are going to study in the factual part. But the question is, how they came to that particular consensus is there in the analysis part. This part becomes a very important point. Is it clear? This is the introduction to the Earth's interior. We are going to discuss the Earth's interior into two parts. One part is what we know right now as given by the scientific community. Whatever the scientific community is given, we are going to see directly. But why we need to believe that one? Who will be explaining why we need to believe that one? The second part called as analysis part. Because of such conditions, it has to be like this. Because of such behavior, it has to be like this. All the reasons are present here. Is it clear? Come on, write down. Give the heading as the Earth's interior. Give the heading as Earth's interior. Earth's interior. Man is not having complete direct evidence. Man is not having complete direct evidence about the Earth's interior. About the Earth interior. About the Earth's interior. There are certain, put like this, instead of there are certain, put like this. The evidences about the Earth's interior are classified into two types. The evidences are the sources about the Earth's interior are classified into two types. What are the two types of sources? One is called as direct source. Another one is called as indirect source. There are two types of evidences or the sources to know the Earth's interior. One is called as the direct source. Another one is called as indirect source. What do I mean by direct? Where you can directly see, where you can directly touch, where you can directly check that one. What is indirect? It might be probably inference and all these things. What are the direct evidences? The direct evidences like, see the direct evidences like, one is called as mining. The direct evidence is like mining, meaning what? He can dig. He can go to the deep inner layers, maybe up to 3 kilometers, maybe up to 4 kilometers. Even that 4 kilometers itself is called as the interior of the Earth. What is there in the interior? He can directly bring the rock material from the deep inner layers. The best example, there are certain mines called as the copper mines. They are the deep parts that are present. Also the gold mines, where the deepest depths are being digged for the extraction of the gold. From there, whenever you are collecting the rock sample, we can directly understand like the interior of the Earth is like this, which is called as direct evidence. We can see the rock, we can touch the rock, we can break the rock, we can study the rock. That is what the mining. Is it clear? Also, the another one called as deep ocean drilling. Deep ocean drilling. It is also a sort of mining. Whenever you are drilling the deep ocean, just to know up to what extent we can drill, that is also the mining type of activity. We can drill and we can collect the rock samples from there, maybe at a depth of 12 kilometers. The deep ocean drilling at a place of Kola Peninsula. At a place called as the Kola Peninsula, man successfully digged up to 12 kilometers. Where this Kola Peninsula of Russia, the Arctic region of Russia. In the Russian region, at a place called as Kola Peninsula, the people started drilling and we have successfully drilled up to a depth of 12 kilometers. That is the known maximum depth. Is it the center of the earth or what? 12 kilometers. No. What is the diameter? 12,800 kilometers. And so the radius should be 6,400 kilometers. We know only 12 kilometers. Just imagine what type of knowledge we are having. Just like, what is not there regarding the knowledge of the universe. Also, the very great essence that is present in the deep inner layer, we are unable to understand. But there are certain one more direct source. What is another direct source? Nothing but volcanism. Volcanism, again, another direct source. What do you mean by volcanism? The other day we were talking about the igneous rock. Magma is coming from the deep inner layers. When the magma is coming from the deep inner layers, where it is coming from? From the inside. If it is there inside the earth, then only it will be coming. When you study the rocks that are coming from the deep inner layers, we can analyze something like, what type of material composition is there. Whether the rock is having the iron, or gold, or silver, or some other material. If it is there inside, then only it will be coming out. Therefore, volcanism also forms a very important direct evidence. These are the direct evidences. Is it clear? These are the direct evidences. But the direct evidences are giving a little bit of information. Up to what depth? Only 12 kilometers. Whereas, the another very important evidence is called as the indirect evidence. See the indirect evidences. The indirect evidences are the one which are giving greater explanation regarding the earth's interior. What are these indirect evidences? Where we can't directly collect the rock material. We cannot directly check whether it is true or false. Whether we can directly see this one. We cannot see all these things, but we can infer. We can interpret. We can analyze. We can believe. Yes, it might be there. This is what the indirect evidence. What are these indirect evidence? Number one, the first and foremost indirect evidence is called as density. Where they are called as density studies. Or else, put it like this, instead of density, let me give directly the other name. This is called as gravity studies. The gravity studies. What will be studying in the gravity? Again, the density itself. The first and foremost indirect evidence is the gravity studies. What do you mean by gravity? What is gravitational force? The earth is acting as a big magnet. Whatever the material that is thrown up, it will be again falling on the surface. Why? Because the earth is acting as a great magnet. From where this magnetic property is there for the earth? From the central part of the earth, nothing but the core of the earth. From the core, what is happening? The very great pulling, attracting force is there, and therefore it is falling. Whenever you say that the source of energy is coming from the deep inner layers, like suppose if this is the earth, this is the source where it is pulling all the material towards its center like this, whenever it is pulling, and so the material from the outside also is coming and sticking onto the earth's surface like this. It is happening like this. When we say this is the one, this is the area called as equator. This is the area called as the poles, right? All you people are well aware of these basic terms. Like this is the equator, this is the pole. From the center, whenever the force is pulling the material towards its center, the force should be equal everywhere. Got the point? From the center, when someone is pulling, the force is equal everywhere. But whenever you are seeing the gravitational force that is acting right from the center along the equator and along the poles, equator's areas are experiencing weak pull. The equatorial areas are experiencing weak pull, whereas the polar regions are experiencing the strong pull. What is the meaning of the weak pull and the strong pull? Nothing but the gravity is very weak over the equatorial region. The gravity is very strong over the polar region. Sir, why it has to be like this, sir? When the pull is one and the same, the material composition in the core is one and the same and it is pulling. Whenever it is pulling, why the equatorial regions are experiencing the weak pull? Why the polar regions are experiencing the strong pull? Why? Because of? Very good. Because of? Very good. What is the meaning? See here. Whenever you are seeing the surface area, where do you find more surface area? Around the equator, you can find very great surface area. As and when you are moving towards the polar region, what happens to the area? The surface area becomes less. The energy that is applied on more area, the intensity will be weak. When the same energy is applied for the smaller area, you will be having greater pull. Is it clear? Meaning what? When the energy, say the energy is 100 units. 100 units of energy is applied for 1000 kilometers of area. Each and every kilometer will be getting how many? Just 0.1%. If the same 100 units of energy is applied for 10 kilometers, then what happens? Obviously, more pull will be there. More intensity is there. Sir, I didn't understand what you have said this. When we say that the center is pulling the same material, when the surface area, whatever may be the surface area, how come there can be difference in the pull? Understand like this in a very simpler way, so that you should be getting a very good clarity. If I say in your language, then you can understand. When I am using the words like surface area, whenever it is more, the energy applied on the surface, more surface area, the weak force is there. When the surface area is less, the force exerted is more. When I am telling this one, the people are unable to understand. Let me put in a different language, like suppose your father is having $1 billion and you are the only kid. You are the only kid here and your father is having $1 billion. What happens? Will you be preparing for civil services or what? You won't be preparing. Got the point? Meaning what? Entire whatever the energy is there applied on one single area, smaller area. Therefore, impact is very high. Now, no doubt your father is a $1 billion worth guy, but you are all 10 siblings. Then what happens? Jagada, Anil Ambani, Mukesh Ambani, all they come into picture. Got the point? Good understand. There are 10 people. When there are 10 people, definitely it needs to be shared equally. Whenever you are sharing the energy on the entire larger area, the intensity of the energy on each and every piece of land will be low. This is called as gravity difference. This is called as the gravity difference, right? Normally, the gravity should be everywhere equal, but it is weak over the equator, it is strong over the polar region. Why? Because as and when the people are moving right from the equatorial region towards the polar areas, what happens? The surface will be keep on decreasing. See, the surface is keep on decreasing like this. Whenever the surface area decreases, the intensity of the pull will be more. Right? That is what the gravity difference is. This is what called as the gravitational studies on the Earth's surface. What is happening? The gravity will be keep on increasing right from the equatorial region to the polar region because of reducing surface area. Everyone clear? Everyone clear? Because of reducing surface area, the gravity will be keep on increasing right from equatorial region to polar region. Fine? This is called as the gravitational force studies. Now, what the scientific community discovered, along the vertical movement, the gravitational force is keep on changing. From latitude to latitude, it is changing. From latitude to latitude, it is changing. Suppose the energy here is 100 units, the energy here is 90 units. Here it is 80 units. No. It has to be increasing. 1 second. Suppose it is 100 units here. Here it is 90 units. Here it is 80 units, 70 units, 60 units, 50 units. This is what the gravitational energy. But what the scientists believe, along the latitude, suppose if this is one latitude, there must not be any change in the gravitational force. There must not be any change in the gravitational force, right? In between this one and this one, there can be a change in the gravitational force because of reduction of the surface area. But along this area, as long as you are moving right from here, there must not be any gravitational changes. But to their shocking, what the scientific community discovered, there are certain specific places where the gravity here is more, the gravity here is less. Here again the gravity is more. Somewhere here the gravity is more. Meaning what? The gravity which is supposed to be more or less in one latitude, whenever you are calculating the gravity of entire the latitude, the gravity needs to be one and the same. But somewhere they are discovering that some areas are not having same gravity. Different gravity is there. Maybe this area is having more gravity, which should not be there. Whatever the gravitational force that is there, same type of gravitational force should be here, but the people are not getting same numbers whenever they are researching. Then they came to know that probably, what is analysis? Probably the material, the rocky material that is present in this part of the earth is more denser. Got the point? Not in the entire globe. In this part of the world where the interior of the earth's material might be denser. This is what the analysis part. This is called as gravity. This is called as the gravity anomaly studies. They're called as the gravity anomaly studies. What do you mean by anomaly? Nothing but changes. Is it clear? No one is going to ask you what do you mean by gravity anomaly studies. But you need to understand the gravity anomaly is one of the indirect evidence, indirect source to understand the Earth's interior. Is it clear? Can there be any question like explain the gravity anomaly of Earth's interior? No. What is the only line that is given in the textbook? Gravity anomaly is one of the indirect evidence. That is what you also need to be writing in your exam. What is one of the important indirect sources? Gravity anomaly. No need to explain what is gravity anomaly. But you need to know what you mean by gravity anomaly. This is what the gravity anomaly is. Is it clear? Along the latitudes, there must not be any change in the gravitational force. But in some areas, you are discovering the gravity changes, which is called as gravity anomaly. This is the one which is giving some evidence to know the Earth's interior. Now we came to know that in this part of the world, some material is denser and so the gravity is more. Is it clear? Meaning what? It is giving some information about the Earth's interior. This is first indirect evidence. This is one indirect evidence. This is called as the gravitational or gravity anomaly. The anomaly study. Write down as gravity anomaly study. What do you mean by anomaly? Nothing but changes, right? Then after this one, the next another important indirect evidence is called as density studies. What is the another indirect evidence is called as the density studies. Here, because of the denser material, what is there? Gravity is more. We are talking only about the gravity. Now let us specifically talk about the density. Whenever you are talking about the density, density is defined as, what is the definition of density? Density is defined as mass per, very good, mass per, let me write like this, mass per volume, unit volume, nothing but mass per volume. This is the definition according to the physicist. What is the density? Density is defined as mass per volume. What the scientific community did, they calculated the mass of the earth. What is the mass of the earth? Even, what is the mass? Density is 5.5, right? They calculated the mass of the earth. Also, they calculated the volume of the earth. When they calculate the mass of the earth, they calculate the volume of the earth. They came to know that the density is 5.50 grams per cubic centimeter. What is this density? This is the average density. the average density of the earth. What is the density of the earth? The average density of the earth, the people came to know that it is 5.5 grams per cubic centimeters. When we say it is average density, when we say that it is the average density, is it the density at the center? No. Is the density at the top? No. It should be at the middle, like this, right? Anywhere between the center and the surface, the density is 5.5. This is what the density is, 5.5. When it is 5.5, what type of density should be, or denser material should be there on the top? Definitely less than 5.5. What type of density should be there at the center? It should be more than 5.5. If it wants to be 5.5 at the center, what type of density should be there at the surface? They came to know that it should be around 2.5. In order to have density at 5.5 in the middle, definitely the maximum density should be around some 13 at the center. Got the point? What they came to know that? They came to know that the density of the earth is 5.5 grams per cubic centimeters. Meaning what? What is 5.5? It's the average density. When we say it is average density, it should not be in the middle or in the top. It should not be the center or in the top. Somewhere in the middle. When it should be 5.5, what should be the least? The least wing should be 2.5. What should be the maximum? It is 13. Then they came to know that the earth is not a uniform denser layer. It is having the rock with varied densities. The rocks that are present at the center are of high density of 13. The density of the rocks that are present on the surface should be 2.5. And when the people are present on the surface, they collected the rock samples and they checked the density of the rocks that are present in and around the surface. They came to know that the density is around 2.5 to 2.7. Therefore, this very experiment proved true. When the least density is 2.5 to 2.7, practically we are checking this one, and practicality is equivalent to the analysis. Whatever we are guessing, the same is happening here. When it is true, definitely it has to also be true. This is what the analysis again. They are taking the rocks from the center and calculating that it is 13? No. But what they believe is, whenever the average density is 5.5, definitely at the center, the rock should be of 13 grams per cubic centimeter density only. That is what the inference, that is called as the density studies. This is how the people came to know about the density variation in the deep inner layers. Because of this density variation only, they believe that earth is not a uniform layer. In fact, it is having different layers. Just like onion. Whenever you are peeling one layer of onion, another layer get exposed. On the same lines, earth is also having different rocky layers. Each and every layer is having different density rocks. This is how they came to one conclusion. Then the other evidence. What is the other evidence? The very important another evidence is the meteorite. The study about the meteorites. The other day we were talking about the meteorites. What are these meteorites? Meteors and meteorite. What is the difference between meteor and meteorite? Completely burnt is meteor. Some residue material that has fallen on the surface is called as meteorite. When we are getting so many meteorites from the outer space, what are these material? In fact, every planet, suppose if this is the sun, let me draw the sun like this. If this is the sun, all these planets that are revolving the sun, in fact, they are having all the small rock debris like this. All the rock debris needs to be collided among each other and needs to form a larger planet. That is called as accretion process. Meaning what? Clearing the neighborhood. Is it clear? What do you mean by clearing the neighborhood? Nothing but whatever the rocky pieces that are present within the orbit, all this rocky material needs to be clubbed to form one larger ball-like structure called as planet. This is how the planet form. What are these small pieces? They are the meteoroids. Got the point? They are the smaller rocky material, they are the meteoroids. When the meteoroid entered onto the earth's surface, and we are calling that meteoroid which is not completely burned as called as meteorite. When you break that meteorite, if you can study, since because of all the meteoroids accretion, the planet is forming, we can get some knowledge about that interior, because what is the basic ingredient for the planet formation? These smaller rocks. If these small rocks are available on the surface, if we can study, they also give some information. If not the complete information, some information is given. Therefore, this is also a evidence to know the earth's interior. This is also a source to know the earth's interior. All they are giving a little bit of information. But there is one source, the final one. This is called as the behavior of seismic waves. The behavior of the seismic waves have given a very great evidence regarding the earth's interior. Out of all the indirect sources, which indirect source is giving great knowledge about the earth's interior? It is the seismic waves. Come and draw this flow chart as it is. Evidences are otherwise called as sources. There are different types of evidences. One is called as direct and one is called as indirect. Under the direct, you can write the three like deep ocean drilling, then mining and volcanism. No need to explain these things, like whenever you are going to drill deep, you can collect the rock samples and can study. Just represent, because you are having the space constraint and the time constraint in your exam. If you can just give that, this is the direct source and this indirect source, that is more than sufficient. Need not to explain what do you mean by gravity anomaly studies, what do you mean by density studies. Just say that the gravity anomaly study is one of the indirect source to interpret the earth's interior. Right? The next one, the density studies, then meteorite, then seismic waves. Then why we are explaining all these things? Though you need not to write all these things, why I'm explaining all these things? Because at least you should be knowing how it is helping the scientific community to know the earth's interior. You should be knowing, though you might not be writing in the exam, but you should be knowing how they are helping. Is it clear? All you people are clear with the gravity anomaly, density studies, meteorites. They are the small rocky pieces formed because of the accretion of small rocky material into larger planet. What is the ingredient of the planet? The small rocks. Whenever you are studying the small rocks, definitely they will give some knowledge, some information regarding the earth's interior. Therefore, the meteorites also form the evidence or the sources. The last one is called as seismic waves. In fact, seismic waves are the one which are giving very great information regarding the earth's interior. But what are the seismic waves? Now give the heading as seismic waves. What are these seismic waves and how they are giving the information regarding the earth's interior? Seismic waves. What are these seismic waves and how they are giving the information regarding the earth's interior? Listen everything, don't write, just concentrate on the concept, whatever the concept we are giving. Seismic waves are also called as earthquake waves. What are these seismic waves? Nothing but earthquake waves. Whenever there is an earthquake, all you people are well aware of earthquake. What do you mean by earthquake? Shaking of the earth. Why the earth has to shake? Because of some disturbance in the deep inner layer. Now, imagine like this is surface. This is the earth. In the deep inner layers of the earth, maybe one person is here. This is the area. Fine. In the deep inner layers, under the foot of this fellow, around some 20 kilometers or 30 kilometers or 40, maybe 100 kilometers of depth, there is a rock. There is a rock. What the earth is made up of? Completely rocks. And is the earth is simply staying just like that or what? It is rotating on its own axis. All we people know that the earth is rotating on its own axis, right? And so we are also rotating along with the earth. Can anyone can guess what is the speed? The speed of the rotation. Are we rotating slowly like this? Or we are rotating fast? What is that fastness? How fast? 50 kilometers per hour? 100 kilometers per hour? 1000 kilometers per hour? 1600 kilometers per hour? Exactly. Now see here. Along the equator, just imagine whenever the earth is spinning on its own axis, where do you find more velocity? It is along the equator. Along the equator, the earth is rotating at a speed of 1600 kilometers per hour. We people feel like the earth is rotating very slow, as if we are moving very slow. Sir, when it is moving very fast, then what should happen? Chakkar aana chahiye, sir, again. Why we are not falling down? Why we are not falling down? When we are rotating at speed of 1600 kilometers per hour, anywhere between 1600 to 1700 kilometers per hour, the earth is rotating along the equator. Along the equator, what is the velocity? 1600 to 1700 kilometers per hour. When earth is rotating such a fast, great fast, what is the speed of our RTC? Nothing but Road Transport Corporation buses. What is the speed of our buses? The so-called the government buses. Maximum of 60 kilometers per hour. What is the velocity of the earth? 1600 kilometers per hour. Just imagine. Earth is not lazy like us. It is moving very fast. Not only it is rotating very fast on its own axis, even it is revolving around the sun with a greater velocity. Per second, it is moving around the sun for 30 kilometers per hour. Per second. For us, second is a negligible time. We will be wasting so many seconds. But 1 second means what? The earth will be moving for almost some 30 kilometers. That is what the fast the earth is revolving around the sun. When the earth is revolving with such a great speed and rotating with such a great speed, what the earth is made up of? Rocks. When it is rotating, what should happen in the earth's interior? There is a constant adjustment among the rocky material. When it is spinning very fast, there is a constant adjustment among the rocks that are present in the interior. Because of the constant adjustment, what happens? Some of the rocks pressures another rock. Those rocks which are weak in nature, when someone is pressurizing from the neighborhood, then what happens? The stress is applied. Because of more and more stress, the rocks became strained and they break. The moment once the rock break in the interior, they releases the energy called as strain energy. They releases the energy called as strain energy. This energy dissipates out in the form of ripples. What do you mean by ripples? Like whenever you are throwing a pebble in the standstill water, you will be finding a series of waves, not just one wave. You will be finding a series of waves. These waves are called as ripples, just like how we can see the ripples on the water. On the same lines, whenever the rock breaks in the earth's interior, it produces a series of ripples like 1, 2, 3, 4. It will be keep on moving out. When the waves are keep on moving out, these waves are called as, these are the seismic waves. Got the point? What are seismic waves? Seismic waves are nothing but the earthquake waves. The moment once there is a disturbance in the earth's interior, the moment once the rock breaks in the earth's interior. What do you mean by disturbance? Nothing but the breaking of the rock. When the rock breaks, why it has to break? Because the stress applied by the neighboring rocks. Whenever the stress is applied by the neighboring rocks, what happens to the rock? The rock becomes strained, and because of the strain it has broken. When it has broken, it has released the energy called as the strain energy. When the strain energy is dissipating out, it dissipates out in the form of a series of waves called as seismic waves. Concept clear? That is what the earthquake is. Now, the moment once the waves are moving out, when the waves are moving out, where these waves touch the earth's surface, where the waves have to touch the earth's surface at the nearest distance. What is the nearest distance? The area which is perpendicular to this point. What is this point? The point where the rock has broken. What is the nearest distance? The nearest distance is the area which is perpendicular where the rock is located. Wherever the rock is located in the inner layers, perpendicularly on the surface, this is the nearest distance. And so, the energy comes onto the surface for the first time along the surface. This area, because of great energy, at once it is pumped out. If there is a house, it gets collapse. If the people are there, they have to, because of the shaking, they have to be an unrest. Whenever there is a big building by the side, it gets collapse, dies. The loss of life and property happens. This is what called as earthquake. What is the literal meaning of the quake? Shake of the earth. The quake of the earth is called as earthquake. The shake of the earth is called as the earthquake. What is the shake results to? Shake results in breaking. That is what called as the break in the rocks because of the shaking. This is called as the earthquake. These are the points. The points are very important. The point where the strain energy is released is called as focus. Very good. The point where the strain energy, which energy got released? Strain energy. The point where the strain energy release is called as focus. This focus is also called as, very good, it's called as hypocenter. Very good. It's called as hypocenter. The point perpendicular to that of the focus on the surface, this is called as epicenter. Very good. It's called as epicenter. Where do you find very great destruction because of the release of the strain energy? It is around the epicenter like this. This is what the area where you can find very great destruction. Entire this area is subjected to destruction. Got the point? This is the area where you can find very great destruction. This is the epicenter. And the waves, these waves are called as, what are these waves called as? This is what the earthquake is. Is this clear? In a very small nutshell, the entire concept is given like this. What is an earthquake? Whenever there is a constant adjustment in the earth's interior, because of the stress applied by the rocks, some of the weak rocks gets strained. When they get strained, they break. They releases the energy called as the strain energy. When the energy is released, the energy dissipates out in the form of waves, series of concentric waves called as the ripples. Whenever the ripples are going out, the movement of the wave takes place, which are called as the seismic waves. This wave comes onto the surface very perpendicularly over to the surface because of the shortest distance, and it creates much damage. That is the area called as epicenter. The point where the strain energy released is called as focus, and the waves are called as seismic waves. Is this concept clear? Is it okay? This is what the earthquake is. In a very, very simpler language, this is what the earthquake is. Fine. Whenever the earthquake is there, then only you can find the spreading of these waves called as seismic waves. How these seismic waves are giving the information regarding the earth's interior? We need to know what are these waves, what are the properties, what are the different types of waves. But before going to see, this is the entire scenario. Come on, write on. Earthquake. Okay. See here, the gravitational force is more on the poles as it is close to the center of the earth. As it is close to the center of the earth, the gravitational force is more. This is what one of the reason that is given by one of our friend. Saying that as the poles are closer to the center than that of the equator. Is it really so? Yes, it is really so. Meaning what? Whenever you are seeing the shape of the earth. No, again we are going to deviate. Let us not deviate. What is the statement given by one of our friends that is also perfectly true? When you are talking about the equator and the polar region, what is the reason I have given for the differential gravitational force? Surface area. What is the main source is the surface area. Because of larger surface area, the gravitational pull is weak. Also, the surface area here is less, therefore the gravitational pull is more. That is the main and very important reason why the gravitational force are different along the polar region and the equatorial region. There is another reason also. What is another reason? Whenever you are comparing the distance between the, suppose if this is a globe, from here the center, and from here the center, from the polar region the center, and from the equatorial region to the center, which is somewhat more in distance from the equator, it is more towards the center, but the distance is somewhat less. How much less? Is it in hundreds of kilometers? Only a few kilometers. Only a few kilometers distance is less. Therefore, it is also one of the reasons why the gravitational pull is more along the equator. But what is the main reason? It is the surface area. Is it clear? This is the doubt of one of our friend. Let us not go into this one. Okay? Now, give the heading as earthquake. What is an earthquake? Come on, write on. Earthquake is defined as, what is an earthquake is defined as? The earthquake is defined as a disturbance in the earth's crust. Disturbance in the earth's crust due to the sudden release of a disturbance in the earth's crust due to the sudden release of strain energy. Due to the sudden release of strain, S-T-R-A-I-N, strain energy. Full stop. Next point. The energy dissipates out in the form of series of waves. The energy dissipates. Dissipates means what? Spreads out. The energy dissipates out in the form of series of waves. A series of waves called ripple effect. R-I-P-P-L-E. Ripple effect. R-I-P-P-L-E. Ripple effect. These waves are called seismic waves. These waves are called as seismic waves. Next para. Write down the next para. Because of constant adjustments in the Earth's interior, some weak rocks undergo stress. Some weak rocks undergoes stress and get strained out. S-T-R-A-I-N-D, strained out, and breaks to release the strain energy. Okay, this is the entire phenomena. Some of the rocks are there, they are stressed and they get strained and they break, they release the strain energy. The energy dissipates out in the form of waves. The waves are called as seismic waves. Come and draw this picture. Mention the parts. The parts are very important. A small diagram makes a lot of difference. Draw a small picture like this. Show that this is the surface of the earth. Show that this is the surface of the earth. A small diagram. Parts are important. Epicenter, hypocenter, focus, seismic waves. Done? Is it okay? Now, come on. Now, what is our target? The target is how these seismic waves are giving the information regarding the Earth's interior. That is what we want to know. Fine. For that one, for this one, what you need to know is how many types of seismic waves. Let us talk about more about the seismic waves. Seismic waves are classified into two types. What are the seismic waves? The seismic waves are classified into two types. What are the two types of seismic waves? One is called as body waves. Very good. The another one is called as surface waves. They're called as the body waves. Another one is called as surface waves. What do you mean by the body waves? What do you mean by the surface wave? Meaning what? If I keep this one aside, this is the Earth. This is the focus where the rock got broken and has released the strain energy. Now, the waves are going through the body of the Earth like this. All the waves that have taken birth from one point called as focus, all the waves are moving out. When all they are moving out, where they are moving? They are moving through the body of the Earth. These waves are called as the body waves. These are the body waves. What is the literal meaning of the body wave? The wave that is passing through the body of the Earth is called as body wave. Then what are surface waves? Where we can talk about the surface waves? Surface waves are nothing but the modified body wave. All the waves are basically the body waves only, but sometimes whenever the energy comes at once, with great intensity, when the energy comes onto the surface, where you can find the energy coming at once onto the surface? The area which is called as epicenter. In this area, the body waves comes very fast onto the surface. Why it has to come very fast onto the surface? Less distance. And therefore, these high energy waves interacts with the low density rocks. What type of rocks are there along the surface? Very low density rocks. These high intensity energy waves interact with the low density rocks and get modified. And get modified as the waves called as surface waves. What is the literal meaning of the surface wave? Surface wave is the wave, the moment once it interact with the low density rocks and turns into surface wave, it never again go into the deep inner layers of the Earth. Once the body waves comes from the inner layers, there is no chance of the body wave again entering into the inner layers. It will be moving along the surface only. Like it comes on the surface, it will be moving along the surface. It comes and it will be moving along the surface. These are called as surface waves. What are surface waves? They are nothing but the body waves, but got modified. How they got modified? Because of the interaction with the low density rocks along the surface. They get modified and they will be moving only along the surface. Or they are having the capability to again go into the deep inner layers. That is what the modification. What do you mean by modification? The change. What type of change is there? The body waves are having the ability to move through the body, but the surface are not having the ability to move through the body. Once they come onto the surface, they will be moving only on the surface. Is it clear? The body waves are of two types. The body waves are of two types. One is called as, let me write here itself because let me continue the flow chart. The body waves are of two types. One is called as the primary wave. One is called as the primary wave. The another one is called as, come on. All these things are known to you. Okay. One is called as the primary wave, another one is called as secondary wave. What do you mean by the primary wave and what is the secondary wave? Listen this one. This is the area where the rock has broken up and it has started the energy. The energy is coming here. Who will be giving the information that the energy reached here? There are certain instruments which can detect the passing of the energy. The name of that instrument is called as the seismograph. It is a seismograph which will be recording the receiving of the waves. What this seismograph, suppose if this is India. What is this one? This is not round, simply round ball. It is our globe where we are living on. Imagine that this is India and India is having the seismographs. And one of the wave came from the deep inner layers and hit our land. Then the land shakes. The moment when the land shakes, what happens? The seismograph will be recording that one wave hit this particular piece of land. Whenever the recording of the wave is there, this is the wave which is called as the seismic wave. Seismic body wave. They said that it is called as the seismic body wave, which reached at around some 10 o'clock a.m. They will be recording like the seismic body wave reached the seismograph at around 10 o'clock. Then they are believing like, there is only one wave, it is coming and hitting. But after a certain time gap, maybe after 10 minutes, what happened? Again the seismograph started recording one more wave. When it started recording one more wave, these people again mentioned that seismic body wave reached around again at 10 a.m. Meaning what? For these people, there should be two earthquakes. Then only the two waves are hitting this area. When these people asked the fellows who are present here at the focus, at the epicenter, is there any other earthquake happen after 10 minutes? They said that no, there was only one earthquake. They said that there is only one earthquake. Meaning what? Just one earthquake is sending not one wave. In fact, from the same point, there are two different types of waves are coming. One has reached first. After a certain time gap, another wave has reached, which is called as second wave. Therefore, they named this one as the primary wave and the secondary wave. One earthquake, as it is sending the wave where it is called as the primary wave and the secondary wave. The primary wave is having the greater velocity. What is the velocity? The velocity of the primary wave is around 7 kilometers per second. Since it is having the greater velocity of 7 kilometers per second, it has reached to the other side of the globe very quickly. Whereas the secondary wave is having the velocity of moving half of that of the speed of the primary wave. Therefore, after a certain time gap, one more wave is recorded in the seismograph. Therefore, then people name this one as primary wave and secondary wave based upon the velocity. Meaning what? Imagine like two persons are running from the same point. The moment once the signal is given, the two fellows started running. One is running very fast, another running somewhat delayed than that of the first fellow. And the first fellow reached on the other side of the globe, called as the primary wave. After some time, the secondary wave is reached. This is what is recorded on the seismograph. Is it clear? These are called as the primary wave and secondary wave. Are these two waves are having the differences only in the velocity? No. When the scientists have discussed or studied more about these waves, then they came to know that these waves are similar to that of longitudinal waves. They are similar to that of the longitudinal waves. What do you mean by longitudinal wave? The wave which is elongated and it will be moving in the form of compressions and the rare fractions. The best example, sound wave. Sound wave is the longitudinal wave. How the P wave is moving? The P wave is moving longitudinally, meaning what? One wave touches the other wave, the energy passes from one touching to the another touching. Likewise, the energies keep on passing. This is called as the longitudinal wave. These are similar to that of the longitudinal wave. These are having the ability to travel or to pass through the mediums like. What are the different mediums? We know there are three types of mediums. One is called as the solid medium. Another one is called as liquid medium. Another one is called as the gaseous medium. These waves are having the ability to pass through all the mediums, but with different velocities. In the solids, they can pass through more than 7 kilometers per second. Whereas in liquids, around 5 to 7 kilometers per second. Whereas in the gases, less than 5 kilometers per second. They're having the ability to pass through all the mediums like solid, liquid and the gases, but with different velocities. That is what the property of the P wave. When they studied about the S wave, the S waves are called as a secondary wave. They are similar to that of the transverse waves. Similar to that of the transfer waves. Nothing but the best example for the transfer waves is a light wave. Light wave, how the light wave will be moving? It is moving very straight. Though it is moving straight, but it is moving slowly. The velocity is less, therefore it is reaching second time, not as equivalent to that of the primary wave. This wave is giving very great inference regarding the Earth's interior because of its unique property. What is that unique property? This wave can move only in one medium called as the solid medium. It cannot pass through neither liquids nor gases. That is a unique property of the secondary wave. Because of that unique property, the scientists, especially the geologists, came to know about the Earth's interior. It should be like this, it must be like this, it may be like this, it can be like this. This is what the inferences. All because of the important wave called as secondary wave. Since it is moving straight, it is vibrating the rocky material, and therefore these secondary waves are also called as shear waves. Meaning what? They are penetrating, they are piercing through the rocks. It's called as the shear waves. Can it penetrate through the water body? Can it go through the gaseous medium? No, only into the solid medium. More the solid, more the velocity. Less the solid material, less the density of the material, less the velocity. That is what the shear nature of this wave. These are all the properties of P waves and the S waves. Come on, write down the properties of P waves and S waves. Give the heading as seismic waves. Give the heading as the seismic waves. Come on, write down. Come on, ask the one. You are asking something.
So can you please repeat why two waves are originating?
See here, what is the question? When there is the release of energy, you are talking about the two waves. One is the P wave, and one is the S wave. Why there are two different modes of movement of the waves? That is what the question. When the point of focus is one and the same, why there are two different modes of movement of the waves? This is what the question. It's because of whenever the energy is dissipating out, it's not like always the energy will be dissipates only in one fashion. There are different varieties of genesis of the waves. Due to this one, the energy that is moving is happening in a different ways. What the scientists discovered that there are two waves of propagation of the energy. One is very fast movement, another one is a slow movement. The very fast movement of the energy is called as the primary wave. Somewhat, the slow movement of the energy is called as secondary wave. Because of the two differences between the characteristics of the energy waves, they are called with the two different names. And when the study was done, they came to know that these can pass through all the mediums, they can pass through only certain mediums. What is that certain medium? Only the solids. Seismic waves are of two types. Seismic wave of two types. Draw this flow chart. And after this primary and secondary, give some space here also, because we need to discuss something here also. Seismic waves are of two types. One is the body wave, another one is called as surface waves. Side-heading body waves. Side-heading body waves. Body waves are the waves that pass through the body of the earth. Side-heading body waves. Body waves passes through the body of the earth. Body waves passes through the body of the earth, and so they are called as body waves. Right? What do you mean by body wave? Why they should be called as body waves? As they are passing through the body wave, through the body of the earth. These are of two types. The body waves are of two types. They are primary waves and the secondary waves. The primary waves and the secondary waves. Side-heading primary wave. Primary wave and the secondary wave. Side-heading primary wave. Primary waves are having greater velocity the primary wave is having the greater velocity of 7 kilometers and more in the solids, are having the greater velocity of 7 kilometers and more in the solids, and so they will be reaching first on the, and so they reach first on the other side of the globe. And so they reach first on the other side of the globe. And so they reach first on the other side of the globe. They are similar to, next point, they are similar to longitudinal waves. And so they reach first on the other side of the globe. Second point, they are similar to the top longitudinal waves. They are similar to the longitudinal waves. Next point, they can pass through. They can pass, PSS, pass through all mediums. All mediums like solids, liquid, and the gases. But they can pass through all the mediums like solid, liquid, and the gases, but with different velocities. But with different velocities. Right? Then secondary wave. See the secondary wave? Secondary waves are also called as shear waves. They are also called as shear. What do you mean by shear? They will be piercing into the rocks, but their velocity is low. They will be shearing means what? They will be moving, piercing through the rocks. When they are piercing through the rocks, what happens? You can literally see the rock vibration. Got the point? When these rocks are, what the geologists did, they send these waves through the rocks in the lab. When they are sending the waves in the lab through the rocks, the rock, whenever the wave is passing, the rock literally shakes. That is what the shearing nature penetrates through the rocks. But it cannot pass through the solid, liquid or the gases. Right? It's also called as the shear waves. They are similar to, next point, they are similar to transverse waves. They are similar to the transverse waves. Full stop. They can pass through only solids. They can pass through only solids. They can pass through only solids, but not in liquids or gases. But not in liquid or gases. Okay, these are the properties of P wave and S wave. Meaning what? The body waves. Let us talk about the surface waves. Come on, give the heading as the surface waves. Give the heading as the surface waves. Surface waves are the modified body waves. Surface waves, first point, come on. Surface waves are modified body waves. Surface waves are modified body waves. As the body waves comes onto the surface, continue this one. As the body waves comes close to the surface, as the body waves comes close to the surface, they interact with the low density rocks at the surface. They interact with the low density rocks at the surface. They interact with the low density rocks at the surface and get modified as the surface waves and get modified as the surface waves. Get modified as surface waves. Full stop. Listen. After the giving the full stop, listen. Just like the body waves, where they are, one wave is running very fast, another wave is following the other wave, and it is moving in all the mediums, another wave is not moving all the mediums. On the same lines, when they got modified, there are two types of surfaces. When there are two waves, one is a P wave and S wave, which got modified, and so they got modified into two another waves. One is called as R wave. One is called as R wave. Another one is called as Q wave. One is called as R wave, another one is called as the Q wave. Listen first of all, don't write anything, I will dictate. First of all, you understand the concept. Making the concept in a very simpler way. Whenever you are reading the other textbooks or something, there are very complex way of explaining. But you write these things, this is more than sufficient for the GS. Right? Just like the body waves, surface waves are also two types. One is called as the R wave, another one is called as Q wave. These surface waves are having such a frequency where they can pass through long distances. Therefore, the very surface waves are also called as long frequency waves. And so they are called as L waves. They are having long frequency, nothing but. What do you mean by long frequency? Short frequency and long frequency. What do you mean by long frequency? Suppose if this is a wave, this is a wave, this is also a wave, right? Both are waves. Got the point? Whenever you are seeing the two different varieties of waves, there are basically two types of waves. One is called as a long wave, and one is called as short wave. What do you mean by long wave? Whenever you are calculating the wavelength, what do you mean by wavelength? If you see the upper part of this wave, it is raising here, and again it raises after a certain distance. These are called as the crests. The lower portions, they are called as the trough. This is what completely the physics concepts, not geographical concepts. But we need to have some knowledge of the physics so that we can understand easily. Whenever you are calculating the distance between one crust and the other crust, this is what called as the wavelength, which is represented by the Greek term called as lambda. No need to know what is lambda and all these things. Sir, you are explaining all the physics and all these difficult parts, sir. We want to know only geography, sir. If at all, even though you are from the non-science background, no need to worry about this one. Simple understand like this. Whenever the wavelength, meaning what? The distance between the two crust, two upper portions, or the two lower portions is large, then the wave is said to be called as long wave. Then the wave is said to be called as long wave. Is it clear? But whenever the distance between one upper part and the another upper part is less, meaning what? The wavelength is less. This is called as short wave. Is it clear? Simply, whenever the short wavelength is called as short wave, whenever the long wavelength is called as long wavelength, long wave, right? What happens whenever what is the difference between the short wave and the long wave? Whenever the wave is having lesser wavelength, then their frequency is very high. What do you mean by frequency? Nothing but repetition is very high. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. How many times it got repeated? The loop got repeated 11 times. Whereas here, the frequency is only 1 and 2. Got the point? Whenever the frequency is more, the distance traveled is more. Whenever the frequency is less, the distance traveled is less. When the energy is more, then only the frequency can be high. And so, when the energy is very high, the waves will be shorter in nature. When the energy is less, what happens? The distance traveled by this wave is less. It's called as low frequency wave. Got the point? Which is a long wave? Which is a long wave? The surface wave. Why? Because they are not taking but from the direct source. What is the direct source? The explosion of the rock or the breaking of the rock. Which are taking birth from the direct breaking of the rock, P wave and S wave. They are having short wavelength. Therefore, they are projecting through the body of the earth and they are coming on the other side. Maybe this is the one called as Nepal. On the other side, it may be USA. The wave is going right from Nepal to till USA. In order to pass, how much energy it requires? Short wave, because it is taking birth from the main source. But whereas this one is a modified form. Is a modified. When it got modified, what happened to the energy? Lesser energy, therefore long frequency. Got the point? Whenever it is of long frequency, therefore it is called as L wave. It's called as L wave. Whenever it is long frequency, can it travel for long distances? No, because it is having less frequency. It is having less frequency. It is having less frequency, and so the distance traveled is less. Now see this one. The movement, once the wave come onto the surface, will it be moving like this continuously throughout the globe or what? Which wave is moving throughout the globe, just like ripples? The P wave and S wave. Is this wave is moving along the surface round the globe? It may be coming only up to the epicenter and dies here itself. And therefore, it is the epicenter which is having the destruction, not the other areas. Meaning what? Again, one more picture. If this is the focus, right? The energy is getting dissipated only up to here like this. Excuse me. Now see here, what is the distance traveled by this wave? Only right from here to here. Not in this area. If it is Nepal, it is confined to only that small area. Why? Because the energy is low, frequency is. Meaning what? The wavelength is long, the frequency is less. When the frequency is less, the distance occupied is less. Therefore, the shaking of the earth is only confined to this region, not in the entire area. Clear? This is what is given here. And so they are called as L waves. What are L waves? Nothing but low velocity wave. They are traveling for the less distance. They are having frequency which is less frequency. Is it clear? This is called as the L wave. What is the area of extent of this surface wave? Very less area. Whereas the P wave and S wave, they can travel from lakhs of kilometers, thousands of kilometers. But these are some tens of kilometers. Is it clear? Now, these waves are of two types. One is called as R wave, another is called as Q wave. What is the R wave? It was discovered by a very great mathematician by name Mr. Rayleigh. R-A-Y-L-E-I-G-H. Rayleigh waves. These are the Rayleigh waves where the direction of propagation of this wave is perpendicular to the surface. Suppose if this is the surface, the moment once the wave comes onto the surface, it turns into R wave, and the wave will be moving in up and down like this, in up and down fashion. This is the R wave. Meaning what? If this is surface, the wave comes and moves like up and down, nothing but creating crust and trough. What is there on the surface? If this is the surface where you can find very tall towers like this. What is there on the surface? We have constructed so many buildings, right? Now, the R wave, whenever it is moving, see here, how the wave is moving? The wave is moving like this. This is the direction of the wave. But, how the surface is there? Surface is like this. How the wave is moving? Up and down, which is called as the perpendicular to the propagation of the surface. The wave is moving perpendicular to the propagation of surface. This is what is happening. Right? Whenever the wave is going like this, what happens when the wave moves? It uplifts the land. The surface was like this. When the wave is moving, it uplifts the land. Whenever the land is uplifted, what is there on the land? All the buildings will get collapse. Where do you find high intensity of collapse? Whenever the wave is in the crust form. Very great intensity where the material is being thrown apart. But when the wave goes to the crust trough part, the intensity of destruction will be somewhat less. Got the point? There may be destruction, but the less impact will be there. But whenever the wave is in the crest form, more intensity and it will be destroying. This is what the R wave, discovered by Mr. Rayleigh. What is the direction of propagation of the wave? perpendicular in the form of crust and trough. Now come to the Q wave. See the Q wave. Out of all the waves, which waves are deadly dangerous? Q waves. Are they more dangerous than that of the R wave? Yes, they are more dangerous than R wave. How they are moving? They are moving direction. What is the direction? If it is the surface, these waves are also propagating perpendicular to the surface, but in the to and fro manner. Earlier the wave was moving like this. In the crust phase, very great destruction. In the trough phase, less destruction was discovered. But these Q waves are moving how? Q waves are moving to and fro like this. Is there any escape? At least, in the trough form, there was some escape for the people. But in the Q waves are moving to and fro. What do you mean by to and fro? This is a surface. When the surface is like this, the surface is made to shake like this. When it is shaken, when the land gets shakes like this, what happens to the structures? All the structures will get collapse. That is what the deadly dangerous wave called as the Q wave, where they are also called as love waves. Why? Because love is more destructive in life. Okay? If there is a question like, love waves are highly destructive, explain. Then don't get jubilated. Yes, sir. Out of all the questions, I know only this question. And start writing. Yes, sir. 10th class love. Fail you, sir. Don't write your love stories. These waves which are highly destructive, they are called as love waves because they are discovered by a very great mathematician by name Mr. A.E.H. Love. Got the point? They were discovered by a very great mathematician by name Mr. A.E.H. Love, and so the waves are called as love waves. Okay, question can be asked like this. They won't be mentioning earthquake, they won't be talking about the surface wave. They will be simply giving the question like, love waves are destructive, explain. Don't get enthusiastic. Write about the surface waves. Got the point? These are the love waves. These love waves are having more frequency than that of the R wave. Meaning what? Which wave is having more velocity? In terms of velocity, which wave is having more frequency? Q waves are having more frequency than that of the R waves. What do you mean by velocity? Nothing but the fast propagation. What is the velocity? Anywhere between 2 to 3 kilometers per second. Suppose if this is the area where earthquake is coming, don't think that, sir, I am a great athlete, I can run. What is the speed of the wave? 2 to 3 kilometers per second. Even though you are going bike, you'll be caught. Right? That is what the velocity of the wave. See the velocity of the wave? 2 to 3 kilometers per second. That is what the velocity of the wave. And these are the very destructive waves. Is it clear? Come on, right on. Surface waves. Did you write about this modification and all these things? Okay, now they are classified into two types. They are classified into two types. R wave and the Q wave. Side heading R wave. Side heading R wave. R waves are also called as Rayleigh waves. Spelling on the board. R waves are called as Rayleigh waves. They are destructive waves. They are destructive. They are destructive waves. Their direction of propagation is perpendicular to the surface. Their direction of propagation is perpendicular to the surface. Full stop. Their direction of propagation is perpendicular to the surface. in the form of crust and trough. In the form of crust and trough. C-R-E-S-T and T-R-O-U-G-H. Trough. In the form of crust and trough. Then siding, Q waves. Out of all the waves, out of all the seismic waves, out of all the seismic waves, Q waves are deadly dangerous. Out of all the surface, out of all the seismic waves, Q waves are deadly dangerous. Q waves are deadly dangerous. Full stop. They are also called as love waves. They are also called as love waves. Discovered by AEH love. Discovered by AEH love. Full stop. Their direction of propagation. Next point. Their direction of propagation. Their direction of propagation in their direction of propagation is perpendicular to the surface. Their direction of propagation is perpendicular to the surface, but in to and fro fashion. But in to and fro movement. To and fro. What do you mean by to and fro? It will be just like, moving just like a snake. Okay. Don't write snake in the exam. Okay. It will be moving to and fro means what? Just like the snake. How the snake will be moving? The wave will be moving like this. Okay? It will be moving to and fro. Whenever it is to and fro, what happens? More destruction can be shown. Right? Out of all the waves which are highly destructive, Q waves. This is about the seismic waves. Meaning what? The seismic waves are basically 4 varieties. Why there are 4 varieties? Basically there are only 2, but 2 got modified into another 2. What are those 2 modified surface waves? What are those 2 original body waves? Right? Now, whenever there is an earthquake, you will come across 2 very important terms in the newspaper. What are the 2 important terms you come in the newspaper? One is called as magnitude. Another one is called as intensity. Have you ever come across the earthquake happened at a magnitude of 8 on the Richter scale? This is what you will be coming across. Now, what do you mean by magnitude? What do you mean by intensity? Come on, tell me now. All you people, many times you might have read in the newspaper. The earthquake of Nepal was at a magnitude of 8 on the Richter scale. This is what the statement that goes like this. What do you mean by magnitude and what is intensity? Come on, tell me. Intensity is the energy. Then magnitude? Magnitude is length of crust. Length of the crust and trough is called as magnitude. Then someone was explaining. Come on. Measure of intensity is magnitude. Then what is intensity? Intensity talks about the destruction. Too good. Then what is magnitude? Wonderful. That is what the answer. See the magnitude and intensity. Magnitude is nothing but the amount of strain energy released. The amount of strain energy released. What is magnitude? Whenever the rock breaks, how much of energy released at the focus is called as magnitude. But what is intensity? Intensity is nothing but because of the amount of energy released, how much destruction happened. It talks about destruction. What intensity measures? Nothing but destruction. Because of that magnitude of energy, how much impact, how much effect is there, called as intensity. Is it clear? This magnitude is referred or measured with the scale called as Richter scale Whereas this is measured with a scale called as scale. Nothing but this is called as modified Mercalli scale. These are the two very, very important scales. When it comes to earthquake, you will be coming across two important scales. One is called as the Richter scale and one is called as scale. Scale is the one which will be measuring the intensity. Richter scale measures the magnitude. This will be having the reading right from 0 to 10. It is having the readings of 1 to 12. What are these two? They are readings. Scale is having the reading from 1 to 12. Richter scale is having the readings from 0 to 10. Both they are the logarithm scale. Both they are the logarithm scales. What do you mean by logarithm scale? Both they are the log scales. What do you mean by log scale? Nothing but the logarithm. The measurement is in the log range. What do you mean by the logarithm? Any change in the whole number, like say for example, there is a change in the whole number. Right? This is what the whole number, entire number. In between what is there? 0.0, 0.1, 0.2, 0.3, 0.4, all the numbers. Right? Any change in the whole number represents a multiplication of 10 times of energy. Got the point? Any change in the whole number is nothing but you need to multiply the energy by 10 times. Any change in the whole number, it is the multiplication of 10 times the power. Whenever you are shifting from one whole number to another whole number, how much of energy is multiplied? 10 times. Meaning what? Imagine that a magnitude of 1. What do you mean by magnitude of 1? Maybe the energy that is released is 100 calories or 100 kilocalories. Imagine like this for our understanding. If the magnitude is 1, meaning what? The energy is given is just 100 kilocalories. If the magnitude is 2, what happens? 100 into 10, meaning what? 1000. 3 means what? 4 means what? 1 lakh units of energy. Every 1 unit, one whole number, whenever it is changed, meaning what? 10 times more power energy is being released. That is what called as the log scale. Is it clear? Is it okay? This is about the log scale. What are the log scale? Log scales are nothing but where the energy is multiplied 10 times for every whole number. It is having the readings from 0 to 10. It is having the readings from 1 to 12. Come on, write down. Magnitude and intensity. Come on, write down like this. Give the heading as the magnitude and intensity. Give the heading as the magnitude and intensity. Magnitude is defined as the amount of strain energy released at the focus. Magnitude is defined as the amount of strain energy released at the focus. At the focus or hypocenter. It is measured with the scale. It is measured with Richter scale. It is measured with Richter scale having the readings from 0 to 10. Having the readings from 0 to 10. Having the readings from 0 to 10. It is a log scale. Nothing but logarithm scale. Simply write as log scale. Then intensity. Siding intensity. Intensity is the measure of destruction. Intensity is the measure of destruction. Is a measure of destruction due to the amount of strain energy released. Measure of destruction due to the amount of strain energy released. It is measured. It is measured with modified Mercalli scale. Measured with modified Mercalli scale. In fact, what is this modified Mercalli scale? In fact, the scale was discovered by Mercalli. Earlier, the readings were 1 to 10. But he modified the scale again from 1 to 12. And so it is called as mm scale or modified Mercalli scale. Scale is called as modified Mercalli scale or also called as mm scale. It is also a log scale. It is also a log scale. Full stop. A log scale is what do you mean by log scale? A log scale is such a scale where the energy multiplies 10 times for every. The energy multiplies 10 times for every whole number. Energy multiplies 10 times for every whole number. Is it clear? This is about the log scale. Here we'll take a small break and we'll go to the other one called as the distribution of earthquakes and volcanisms. Then we'll talk about the impacts of the volcanism. Then we talk about the other things like the different varieties of earthquakes. The impacts of earthquakes and the varieties of earthquakes. Also we'll be talking about the distribution of earthquake, not volcanism, okay? We'll be seeing these things after the break. Let us go for a small break. After the break, we'll talk about the other things. Yes, welcome back. Give the heading as different types of earthquakes. Different types of earthquakes. What do you mean by different types of earthquake? Sir, earthquake though is a disturbance. जोर से disturbance. हल्का सा disturbance. Is it the one or what? What are the different types of earthquakes? What is the meaning? Is it the one? No. Based on what? What is the nature of the force that is triggering the movement of the earth? Based on the nature of force that is triggering the movement of the earth is called as the different types of earthquakes. Come on, give the heading as the types of earthquakes. Types of earthquakes. One. The first and foremost one is called as a very massive, called as tectonic earthquakes. It's called as the tectonic earthquakes. The very important one is called as the tectonic earthquake. After the tectonic earthquake, the next one is called as volcanic earthquakes. Then, the third one, which is very, very important, is called as anthropogenic earthquakes. Anthropogenic earthquakes. What do you mean by anthropogenic earthquakes? Human-induced earthquakes, nothing but. Can the man create the earthquake or what? In the insurance, we will be creating so many things like, if at all you want to claim the insurance of the car, you will be hitting yourself and you will be claiming, see, this is an accident that happened. If at all you want to claim something like, accident, like fire accident, you will be putting some fire and you will be claiming the insurance. But can you claim the earthquake insurance? Can you create an earthquake? How can the man can create? He never creates. He can induce. That's why it is called as human-induced. Human-induced earthquakes. What are the human-induced earthquakes? Like, number one, it's called as collapse earthquake. What do you mean by collapse earthquakes? It is basically in the mining areas. Suppose if this is the, listen, just give the heading and simply listen. I am going to discuss each and everything, okay? First, you need to get understanding about this one. What is called as the conceptual clarity should be there. This is a surface where the man is there, right? Might be in this area, huge gold was there. Very great quantity of gold is there. Do you think that this fellow will be sitting calm or what? Knowing that Under this one, gold is there. What he wants to do? He wants to bring it back. When it wants to bring it back, that fellow will be drilling. The moment once he comes in this area, he'll be taking all the gold and he'll be throwing all the gold out. Then what happens to this place? There's empty space. When there is empty space, there is no support for this piece of land. Then all of a sudden it collapses. The moment once it collapses, here the rocks get breaks. Whenever the rocks break, what is the phenomena called as? Earthquake. Where the rocks are breaking? In the interior. That is called as the collapse earthquake. Right? The next one. After the collapse earthquake, a very, very important one called as explosive earthquakes. Explosive earthquakes. What do you mean by explosive earthquake? This is surface. In the deep inner layers, the man goes in the deep inner layer, maybe 3 kilometers, maybe 4 kilometers, and here in this gap, he'll be placing the bomb and he comes out. What is that bomb? This is called as the nuclear explosions. What do you mean by N-bomb? Nothing but nuclear bombs. Whenever the nuclear tests are conducted, like you know what happened during 90s, all the world countries are looking down at India. What we did, we went to Pokhran. Do you know Pokhran? Did you see that movie called as Paramanu? Such a wonderful movie. Sir, always we see only Dil to Pagal hai sir. नहीं चलेगा वो तो पागल है ही आप परमाणु देखिए got the point. You need to watch some movies which are giving very great information to you. How the world countries like America is checking every country. He is spying every country at every point of time. Do you know this one? Even today, someone was spying on us. Who is that someone? It is America. Every time, because of this GPS, global positioning system, all the satellites are there, they'll be keep on seeing each and every country, what the people are doing there. We people, you know, we don't know anything. We'll be keep on doing the works, going here and there, but someone is watching. There's a third eye. They'll be seeing at us. Yesterday it was here, today it was here. Okay, today it is here. Then they will be questioning, why the fellows have shifted that one to this one? And they'll be calculating. In this process only, what happened? One fine day, when this this country, what is it called? Iran. The country called as Iran wants to develop the nuclear reactor. What is a nuclear reactor? The nuclear technology is a dual-edged technology. From the same energy, that means what? From the same fuel, you can produce the nuclear bombs as well as the electricity. Without any knowledge of any other world countries, these people are trying to build a nuclear reactor. Who are these people? The Iran people. Then immediately America came into picture. They said that Iran is constructing the nuclear reactor. You, Iran, you stop that one. No sir, I didn't construct sir. Okay. Kahani mat bolo. This is what the US said. The same is the case happened. Even in the case of China. What happened? One fine day, the country China is, it wants to develop the friendly relations to all the different countries, with all the different countries, especially in its neighborhood. This was the statement given by China. One fine day, it announced that I want to develop a very great friendly relations with the neighboring countries. When the statement was given, why this statement was given? Unnecessary statement, untimely statement given by China. What is the real thing that is happening? Then US was spying. More satellites were brought on China and they are spying the China. What these fellows do, the Chinese, suppose if this is the one, suppose if I draw a small map, this is what the India, right? This is Southeast Asia. This is Indonesia, this is Sri Lanka, right? This is somewhere here it is. This country, right? These people came to Myanmar, this is Myanmar. They came to Myanmar and gave a proposal. What is the proposal? Myanmar, give me your port. There is a port called as Sitwe Port. There is a port called as Sitwe Port, which is a very old port. I want to do a very great friendship with you. I want to develop a very cordial relations with you. If at all you are giving that port to me, I will develop that one on international standards. Modernization will be done. No need to pay any single NP for me, because as a token of friendship, what you can do after the development, you can allow my navy to stay here. Then it's a beautiful proposal for the country. Then they said that, come on, क्या चाहिए आपको? सिटी चाहिए, सिटी के साथ जो भी चाहिए वहां पे ले लीजिए. This is what they said. Then the China developed so modern port, and the port became so sophisticated, and this is a Sitwe port. Now who is staying there? Navy. The Navy of China is staying there. Then they went to Bangladesh. They kept the same proposal. Why don't you give me one port? I will be developing on a modern scale, on the modern lines. But allow my navy to stay there. And Bangladesh gave Chittagong port. The name of the port is called as Chittagong. Chittagong port. Then they came to Sri Lanka. Sri Lanka people are very sharp. No, China, just wait. You are going to do friendship with me? You are going to modernize my port? Come on, le lo ek port. What is the name of the port called as? Hambantota. The name of the port is called as Hambantota, was modernized, developed on the modern lines. Then they went to their old friend. The name of the port called as Gwadar port. When all the ports are being developed, even the Maldives, there is a port called as Maoria port. When all the ports are being developed by China, what the India was doing? इनको कुछ काम नहीं, यहाँ वहां जाके ports develop कर रहे. This is what India was thinking. Who was monitoring all these things? It is USA. Then USA, the United States Foreign Secretary, came out with the proposal, saying that, come on, jago India, jago, kya hua tumko? Come on, jago. You know what? Then India got, what happened? He said, what you are thinking, what China is doing, they are constructing all the ports around you. Okay? Oh, is it, sir? Really? Yes, they are constructing. See this one. If anything goes wrong, the Northeast India will be attacked by the Myanmar port. If something goes wrong, from Chittagong, Calcutta will be attacked. From the Sri Lanka, Tamil Nadu and the Vizag can be attacked. From the Maoria port of Maldives, you can find the Cochin can be attacked. From the Gwadar port, Bombay can be attacked. And you are surrounded. You are unaware. Who gave this statement? Not our intellectuals. Not our RAW. Who gave this statement? It is USA. Because they are looking everyone. They are spying on everyone. This is the concept called as. It's called as. Who gave this statement? It is also the coining of the statement itself is made by United States of America. They call it as the string of pearls around India. You mind, you are being surrounded by China. This is what the concept given by USA. How do they know? When we are here in between, we are unable to understand. Where are they? Exactly opposite on the other side of the globe. Though they are there on the other side of the globe, they are looking. Every time they will be looking at it. They don't have any other work. इसमें घर में क्या चल रहा है? इसके घर में क्या चल रहे हैं? Do you understand? This is what you say. You don't know. Right now you people feel like, this country is a very enemy country. Which country? China. This is what you people and me, everyone is believing. But out of all the countries, which is a deadly dangerous country, it is USA. Is it clear? That is what USA. Right from the beginning, it is like this. It will be working in such a way that it will be cutting something out of your body. You won't even know that one. That is what USA is. This is a very crooked country. Is it clear? And thank God we believed our old friend called as Russia. Right? We believe always in Russia. That's why what happened in the case of Ukraine-Russian war? Whom we supported? Russia. What do you mean by support? Are we sending the arms and ammunition or what? No, we are silent. Silent itself is a support. We are not speaking against. जब दोनों झगड़ा कर रहे हम ऐसे देखने से करने दो. That is what the support. Got the point? What was our foreign policy? Our foreign policy is always to support the weak. Right from 1947, the moment once we got independence, right from then till 1990s, what was the foreign policy? To support the weak. That's why in the Israel-Palestine conflict, we supported Palestine till 90s. In every part of the world, wherever the conflict happens, we will be supporting only the weak. But gone are those days. Now we got changed. What type of change? Now we are supporting Russia, which is strong. Now we are supporting Israel, which is strong. Got the point? The changed equations are there. Now the foreign policy got completely changed. There is a wonderful book called as The Elephant Can Dance. Very good. You know, there is a wonderful book called as The Elephant Can Dance. Try to get this book downloaded. That is available free of cost in your internet. Try to read at least one page every day. More than sufficient. Wonderful book. Where you can come across all the foreign policies, what type of foreign policy, what is the shift in the foreign policy, and all these things you can understand. Right? See, this is what the civil service is. All you need to know. What happened in the past, what is happening in the present, and what are the real colors of the different countries. All these things you should be understanding. Is it okay? This is about the watching, spying of America. Is it clear? See, this is what the explosive earthquake. When we want to prove ourselves like we are a strong, technologically strong country, we want to go for what is called as the nuclear explosions. In the state of Rajasthan, we selected one small village called as Pokhran. In the deep inner layers of the Pokhran, we want to go for nuclear explosion. And it is a highly successful story for the country called as India, where not even a single country in the outside world were aware of this one. But the moment once we have exploded, this is the bomb. When it got exploded, what happened? The rocks got broken. When the rocks break, what happens? The P wave, S waves start running from here to all parts of the world. And this is how America came to know that. After their seismograph recorded the P wave, oh, somewhere bomb put gaya. This is what the people came. Got that one? Where is somewhere? Then they came to know about the focus. Where is the focus? The focus is there in India. Then it is USA announced, yes, India has test fired the nuclear bomb. Is it clear? This is how the people comes to know. Then this again man-made, explosive. Then the third one, very, very important one, called as reservoir induced seismicity, popularly called as RIS. Question in the UPSC can be directly asked like this. What are RIS? Explain the impacts of RIS in India. If you don't know what is RIS, you might be knowing all the impacts of the seismicity and nothing but the earthquakes, but you will not be writing the answer. We feel like RIS is something new. What is RIS? Nothing but reservoir induced seismicity. Sir, reservoir we know, sir, but how can the reservoir can trigger earthquake? What do you mean by reservoir induced seismicity? Reservoirs are triggering the earthquake. Can the reservoir trigger the earthquake? Yes. How? Listen this one. This is the area where the sea and the land is there. Right? Maybe this is the Bay of Bengal. Maybe this is the India. Suppose if this is a river that is flowing like this. What is the river? River is always the fresh water. What is the sea? The sea is always salt water. We people want the fresh water. Therefore, in the name of irrigation, in the name of wanting more water, what we'll be doing? We never allow the fresh water to flow directly into the salt water, or it is called as construction of dams. Whenever you are constructing the dam, what can happen? This is the aerial view. Meaning what? the top view. This is the top view. Now look at the picture, the same picture from the side view. This is the top view you are seeing from the top. Now I am drawing the picture from the side view. This is the surface. This is the Bay of Bengal. This is the river that is flowing. Side view. Is it clear? Now what we did, in want of more and more water, we have constructed a dam. When the dam is constructed, what happens? The water gets stored. How much time will be taking constructing the dam? 100 years or what? 1 year? 2 years? Now, until this point of time, the rocks that are present in the deep inner layers, these are the rocks that are present. All the rocks are present in the deep inner layers, were not having any pressure. They are very free, they are very calm, nothing was happening. Because of bringing so much of greater concrete from different areas and dumping in this area, what happened? Pressure increased. Not only the pressure of this concrete that was increased, also because of the storing of the water started creating more and more force. Now the rocks are under stress. They are under high stress. Until this point of time, there was no stress at all. Now they are under heavy stress. When the stress is happening, exactly during this point of time, what happened? Because of storing of this water for some more time period, the water percolates. When the water percolates, what do you mean by percolation? Seepage of water. When the water goes slowly into the deep inner layers, that rocks that are present get wet, the rocks becomes wetter. When the rocks become wetter, they are very susceptible for breaking. The moment once it triggers, meaning what? It breaks, it releases huge strain energy. Such a earthquake is called as the reservoir induced earthquake. Is called as RIS, reservoir induced seismicity. Is it clear? There are many such dams that are there which have triggered the earthquakes. That is the reason every time whenever the government of India wants to construct any dam in the Himalayan regions, the environmentalists protest. The environmentalist comes into picture. They will be saying, no, we don't want any developmental project. Let you leave the land as it is. If at all you are going for the construction of any developmental project, it will changes the slope of the land. It will changes the geomorphology of the land and may trigger some disasters. These were the disasters. Is it clear? This is called as the reservoir induced seismicity. This is the reservoir induced seismicity. Then all you people know one project called like Chipko movement. What is this Chipko movement? Hugging. Hugging what? Trees, not someone, okay. It's called as the Chipko movement, going and hugging the trees. Why the people are this great personality like Sundar Lal? Come on, you people, what is the problem is, you know everything, but you are unable to connect, that's it. Sundar Lal Bahuguna, this is a great personality who initiated the program. Also, other people, who are that women folk who are connected with this movement? Don't say Medha Patkar. Yes. The next one. Then, only one personality. See, in the Chipko movement, some of the women leaders became so popular. Right? These people, they started hugging the trees. Why they started hugging the trees? Because the government wants to go for some developmental project. Whenever any developmental project needs to be constructed, they need to clear the land. They need to cut all the trees there. If at all you are cutting the trees, what happens? The soil that is anchored with the roots will be removed. When there is no anchoring of the soil erosion takes place. Deforestation happens. Because this one, the land gets degrades. These are all the impacts that are going to happen whenever you are cutting the trees. Therefore, the people hugged the trees, nothing but embracing of the trees. Not only the Chipko movement, is there any other movement like this? There is a movement called as Epico movement. Write somewhere, try to check all these things. Chipko movement, Epico movement, all these are the important movements that have happened already in India. What is this one? See, I can't explain each and every movement. Whenever there is a point is there, I will be giving the information. You catch that one and you will be digging more. Try to know more and more information. Right? This is what the reservoir induced seismicity. Then, the next one is called as explosive. The next one, collapse earthquake. Then what about these two? The tectonic earthquake. What do you mean by tectonic earthquake? Nothing but whatever the explanation we have given in the first half. What is the first half? Whenever the earth is in a constant adjustment, the rocks break and triggers the earthquake. That earthquake itself is called as tectonic earthquake. What do you mean by tectonic earthquake? There are certain adjustments that are happening continuously in the earth's interior. Because of those adjustments, some of the rocks, the weak rock breaks. Whenever the rocks breaks, what happened? The strain energy released. That is called as tectonic earthquake. Then what do you mean by volcanic earthquake? Whenever the magma is pumping up onto the surface from the deep inner layers, if this is a surface, this is a magma chamber. Wherever the rocks are weak, what the magma will be doing? It will be pumping. It will be punching. The rocks are punched. Who will be punching the rocks? Magma. Magma punches the rock. Whenever the rock is punched, what happens to the rock? The rock breaks. When the rock breaks, what we call this one as? Earthquake. Whenever the rock breaks, it's called as earthquake. That is the reason many times wherever the volcanism is happening, definitely that is a zone of earthquake also. There is no separation of earthquake zone and the volcanism zone. Both the earthquakes and volcanoes happens at the same place. Got the point? All the volcanic places are earthquake zones. Is it clear? Can we say the statement in the same different way? All the earthquake zones are volcanic zones? No. But all the volcanic zones are earthquake zones. Is it clear? Because whenever the magma punches the rocks breaks. Whenever the rock breaks in the interior, it itself is called as earthquake. Is it clear? These are the different varieties of earthquakes. Come on, write down. Types of earthquakes. Everyone has written all these things? Oh, you are too good. Shall I move ahead or what? If one person says no, I will stop. Shall I move ahead? Or I need to dictate or what? Come on, write down. Types of earthquakes. What are the different types of earthquakes? The first one, tectonic earthquake. Tectonic earthquake, hyphen. Under this one, write down. What is the tectonic earthquake? There is a constant adjustment in the earth's interior. There is a constant adjustment in the earth interior. There is a constant adjustment in the earth's interior due to which the rocks break. Due to which the rocks break. Due to which the rocks break. Okay, this is the tectonic earthquake. Then collapse, not collapse, what is it? Volcanic earthquake. Volcanic earthquake. When magma punches out, when magma, M-A-G-M-A, magma punches out, when magma punches out, it breaks the rocks interior. It breaks the rocks interior. It breaks the rock in the interior. This is what the meaning. It breaks the rock in the interior. It breaks the rock in the interior, which is nothing but volcanic earthquake. Nothing but volcanic earthquake. Then human induced earthquakes. The third one. Human, H-U-M-A-N. Human induced earthquakes. Under this one, number one, collapse earthquakes. Collapse. This is also called as mining. This is also called as mining earthquake. What is the meaning? When the required material is mined out, when the required material is mined, M-I-N-E-D, mined out, when the required material is mined out, the roof, ROOF, roof lacks the supports from the bottom. The roof, ROOF, roof lacks, LACKS, lacks support from the bottom, and the roof collapses. The roof collapses, breaking the rock at the floor. Breaking the rocks at the floor, inducing earthquake. Inducing the earthquake. Okay? Inducing the earthquake. That is what the collapse. Then, explosive earthquake. Explosive. No, sinkholes are something different. You cannot say that one as collapse, Sinkholes, they won't fall all of a sudden. Just like, in the case of mining, because of human induced, they will be falling. Sinkhole is a natural one. Okay? We'll come to that one. What is a sinkhole and all these things. Explosive earthquake. Explosive earthquake. When the nuclear or the atomic material, when the nuclear or the atomic material is test fired, when the nuclear or the atomic material is test fired in the deep inner layers of the earth, it triggers earthquakes. It triggers, TRIGGERS, triggers earthquake. It triggers earthquake. Then, the reservoir induced seismicity. See, you can draw small pictures like this. If at all you are drawing the small pictures, you can understand very easily. Okay, reservoir induced seismicity. Due to the construction of the heavy dams, the water gets stored. Due to the construction of heavy dams, the water gets stored and exerts more pressure. And exerts, exerts more pressure on the underground rocks. Moreover, the seepage of water, SEEPAGE, seepage of the water. Moreover, the seepage of the water. What do you mean by seepage? Nothing but percolation of the water. Okay? Seepage of the water makes the rocks wetter. Makes the rock wet. Or nothing but they will be in a moist condition. Okay? Makes the rocks wet, which can break easily. Triggering earthquakes. Okay, that is what called as reservoir induced seismicity. These are the different varieties of earthquakes based on what? How the earthquake is taking birth. Nothing but based on genesis. Based on genesis, there are different varieties of earthquakes. Like, one is called as tectonic, another one is volcanism, another one is the human induced. But there are different another classification like based on, write down as based on depth. Based on depth of the focus. Based on the depth of the focus, earthquakes can be of three types. Based on the depth of the focus. What is the focus? The point where the rock is getting broken. Right? The point where the rock breaks is called as the focus, otherwise called as hypocenter, right? Based upon the depth of the focus, the earthquakes can be of three types. What are the three types? One is called as shallow earthquake. The next one is called as medium earthquake. The last one is called as deep earthquakes. Based on depth of the focus, the earthquakes can be of three types. One is called as shallow earthquake. The next one, medium earthquake. The last one, deep earthquakes. What do you mean by the shallow, medium, or the deep? If the focus is located less than 40 kilometers of depth, write down shallow earthquakes heading. If the focus is located at less than 40 kilometers of depth, is called shallow earthquake. If the focus is less than 40 kilometers of depth from the surface, is called as shallow earthquake. Out of these three, which is the very intense intensity can be there? Which is deadly dangerous, shallow or deep? Shallow. Why? Very close to the surface. Within no time, the energy waves comes onto the surface with greater intensity and creates so great destruction. The earthquake that happened in the Nepal in the recent past is a shallow earthquake, where the focus was at 38 kilometers. Just imagine. The focus was at 38 kilometers, very close to the surface. Therefore, the very great destruction happened. This is what the shallow earthquake, right? When the focus is at less than 40 kilometers, it's called as shallow earthquake. When the focus is located anywhere between 40 to 250 kilometers, it's called as medium earthquake. Sir, how can it be 250 kilometers, sir? You can see the breaking of the rock even beyond 250 kilometers. Meaning what? Below the astrosphere also. Got the point? It's a medium earthquake. If there is a focus which is beyond 250 kilometers, is called as deep earthquakes. Deep earthquake, even though it is of high magnitude, but the impact will be very less. Why? Because by the time the waves come onto the surface, they become weak. When they become weak, they can't create much destruction. Is it clear? Now, see, whenever you are seeing these numbers like 40, 40 to 250, beyond 250, what idea should be there for you? What idea should be there? The rocks can break. Suppose if this is a surface, it is where we are. The rocks can break at the depth of more than 250 kilometers also. Whenever the rocks are breaking at the depth of more than 250 kilometers, the waves will not be waiting for there itself. They will not be striking up there itself. They will be coming onto the surface like this. But the problem here is, by the time they consume so much of energy to reach here, because of consumption of energy, the waves are having less energy, but they will be creating mild or less destruction. Therefore, the deep earthquakes always are not to be considered, because their impact is very less. Which earthquakes are very important earthquakes where the heavy destruction can be there? It is the shallow earthquakes. Right? Shallow earthquakes are very deadly dangerous. This is about the shallow, deep, and the intermediate or the medium earthquakes. This is about the based on focus, is based on genesis. This is about the classification of the earthquake. If there is a question like classification of the earthquake, you need to mention both the one. The classification of the earthquake can be done based on genesis. Based on genesis. What do you mean by genesis? The origin. Based on genesis, nothing but origin. Another one is based on depth. These are the two classifications. Then move to the next heading. What is the next heading? The distribution of distribution of earthquakes and volcanism. Let us see at a go. Let us see at a go. What is this at a go? Meaning what? Though we didn't discuss volcanism till now, but let us see the areas where the distribution of earthquakes and volcanisms are there. The distribution of earthquakes and volcanism is not happening haphazardly. Meaning what? Wherever the land is there, we cannot see the earthquakes. Wherever the ocean is there, you can't see the volcanism. All they are happening in a very, very disciplined manner. We cannot find the earthquakes wherever we like. All the earthquakes and volcanisms are happening at a prescribed area. What the human discovered is, all they are happening at certain locations only, but till 20th century, the people are unaware of why they are happening only there only. Got the point? Till the 20th century, the man is simply unaware like why the volcanism is happening only there. Why the earthquake is only happening there. What they can see is, yes, earthquake is happening. What they can see is, yes, the volcanism is happening. But what they can't figure out is why they are happening there. Till what time? Till recently. Till 20th century, the man is unaware. Recently, because of the development of the very great concept called as the plate tectonics, the people came to know that, yes, the earthquakes and volcanism can happen only in certain areas. Till that point of time, this concept was so popular. The distribution of earthquakes and volcanism, where they are happening, the people are well aware of the areas, but they don't know the reason behind. Even today in the class, we will be discussing the areas only. We will not be discussing the reason behind the earthquake and volcanism. Where we will be coming across the reason? In the plate tectonics. Is it clear? Come on. What are the areas? The first and foremost area. The first and foremost area where more than 70, means more, around some 70%, more than 68% of the world volcanism and earthquakes are happening in just one area. It's called as, very good, it's called as the Pacific Ring of Fire. This is also called as Pacific Ring of Fire. See the name? The name is called as simply Ring of Fire. Also it can be called as Circum-Pacific Ring of Fire. What is this Circum-Pacific Ring of Fire? Right? Give the heading as the distribution of earthquakes and volcanoes, and write on the first place where you can give one number. More than 68% of the volcanism and earthquakes are restricted to one area. What is the name of the area? Circum-Pacific Ring of Fire. What do you mean by the Circum-Pacific Ring of Fire? Listen now. Suppose if this is the world, this is the North America, this is the South America, right? Simply, roughly like this. And this is India, this is Russia, this is Asia, Indonesia, this is Australia. This is Japan, this is Philippines and all these things, right? This is called as the Pacific Ocean. This is the Pacific Ocean. What do you mean by circum? What do you mean by Circum-Pacific Ring of Fire? Nothing but the circumference. What do you mean by circumference? Around the body. If this is the Pacific Ocean, around the Pacific Ocean, like this, let me take a different color like this one. Around the Pacific Ocean, right from the tip of South America till the Central America, then North America, along Russia, then Japan, Philippines, Southeast Asia, Indonesia, the islands that are present. What are the islands here? It's called as the Southwest Pacific Islands. And all these Pacific Islands, all these are the areas. In all these areas, when the people are calculating how many earthquakes are happening, how many volcanisms are happening, they could see that more than 68% of the world's volcanism and earthquake are happening only there. What they can calculate is how much percentage that is happening. But what they don't know at that point of time was why they are happening there. Whenever the geographer is not giving the answer like why they are not happening, it's an insult to the geographer. Then the revolution started. Because of this small concept only, there was a revolution in the scientific community. Due to that revolution, they came up with a very great concept called as the plate tectonics. The plate tectonics has given very great, wonderful reasoning why the earthquakes are happening there, why the volcanisms are happening there. We'll be discussing all those things. The concept like a shadow zone, like concept of volcanism, earthquakes, why it is happening, everything will be discussed there. Right? This is about the Pacific Ring of Fire. Is it clear? It's also called as circum-Pacific. Along the circumference of the Pacific Ocean. This is what the area. How many earthquakes and volcanisms? More than 68%. The next area. The next area is called as the second area is called as the continental belt region. Is called as alphinoid. Alphinoid region, also called as mid-continental belt. Mid-continental belt is called as alphinoid or also called as mid-continental belt. How much of percentage? Around some 21%. Around some 21% of the volcanism of the earth and the earthquakes are happening here. What is this area? I hope all you people brought the atlas. Right? Brought the atlas. Shall I show some of the mountains? Let we start right from today. Open the atlas, come on. For the past 1-2 days, I am not asking you to open the atlas, right? See here, what is the strategy? We will be learning the map pointing along with the subject. If at all you are seeing only the map pointing, then what happens? It will get faded away from your mind very easily. When you learn the concept and when you see the place, then you can remember the place for quite long duration. Now, those people who are not having the atlas, never mind. You can peep in the other's atlas. Okay? But from the next class onwards, don't try to peep in the other's atlas. Right? Right now, yes, you can see you can share. Whoever is having, by side, then you can check the one. Oh, almost all, 80 to 90% of the people are having atlas. Wonderful. I appreciate. I salute you. Too good. You please adjust yourself. Whoever is not having the atlas, you please make comfortable yourself. Go and sit by the side of the person who is having the atlas. Don't take this as an advantage. Go and sit in all whatever the favorable places are there. Okay? Wherever the atlas is there you try to sit. Okay? Come on. Go to Europe. Now, whatever the mountains I am representing, you please write it on the paper also. Along with you need to check in the atlas. This is the mid-continental belt. What is the name? It's called as middle continental. Meaning what? In the middle part of the continent, there are continuous chain of mountains. What are those mountains? What is that middle part? It starts right from Europe. It starts right from the Western Europe till Asia. Which Asia? Southeast Asia. From where to where you can find the chain of mountains continuously. It starts from the Western Europe till Asia. Where you need to see? You need to go to don't go to the world map, go to the Europe map. Go to the Europe map. Every time, whenever you are opening that atlas, you will be seeing two maps. Same structure, two maps will be there. How to read atlas? Come on. How to read atlas? How to read atlas? Whenever you are seeing any continent, you talk about any continent, whether it may be Asia, Africa, Europe, whatever the continent, when you open the atlas, you can see two maps. One is called as the physical map, another one is called as the political map. One is called as the political, another one is called as the physical map. What is a political map? Political map denotes only the political divisions of the countries. The political division of the continents, like which continent is having what, how many countries, or which country is located. Each and every country is differentiated with a different color. Like whenever you are seeing the Europe map, right now you are in the Europe, see the political map, you can find different colors in the political map. Like UK was given in one color, Ireland is given in one color, Greece is given in one color, Italy is given in one color, France, Spain, Portugal, all they are different colors. There is no much explanation for identifying the country in the political map. So it is not our task. What is our task? Since we are in the physical geography, identifying the physical entities on the map is a task. Is it clear? What do you mean by the physical map? The physical map is the one which is representing not the countries, the political divisions. It is representing the physical divisions. The physical divisions like mountains. It represents plateaus. It represents plains. It represents shallow waters. It represents deep waters. All these are represented. How we can represent mountain? Is there any, on your atlas, is there any elevated structure is there? Oh, yes, sir. Yes, sir. It bits, sir. Therefore, it is mountain. Is it the one? How it is represented? All it is differentiated with a specific color. There is no question of change of color from one atlas to another atlas. Is it clear? In the political map, different colors according to the will and wish of the publisher, they may be using in the political, but not in the physical. They can't use any different color. As a rule, as a condition, the cartographers, who is a cartographer? The person who is making the map. The person, nothing but the cartographer, advises the people not to use different color. When one specific color is given for mountains, that color should be there as a universal color for all the mountains, for all the atlases. In all atlases. There is no chance of giving red color, green color, brown color, or different colors in different publishers. No. There is no chance of giving different colors. Right? How it is represented? See the physical map. When you see any physical map, by the side there will be a scale. The scale will be like this. You talk about any physical map, by the side there will be a scale. Is the scale is there for the Europe? Right? What is the scale? The scale is nothing but the two parallel lines. There are two parallel lines, but one line cuts the other line. Wherever it is cutting the other line, that is the area called as mean sea level. It's called as the mean sea level. Clear? Wherever the two parallel lines intersect, that point is called as the mean sea level. Meaning what? If you go below the mean sea level, you will be there in the water. If you come above the mean sea level, you will be there on the land. Clear? Now, let us go below the water. The moment once you go one step below the water, it is represented with the blue color, which is called as the light blue color. Very, very light blue color. Just by the side of the continents, which is a narrow, very narrow color, narrow area where you can find the very light blue color. Are there light blue colors? What do you mean by very light blue color? Nothing but all those areas are the shallow depths. Maybe less than 100 meters, maybe less than 200 meters, maybe less than 300 meters according to the scale. Whatever the number that is given in the scale, like if it is given like 500 meters, less than 500 meters. What do you mean by light blue color? Wherever in the physical map, whatever the company atlas may be. If at all you are seeing the light blue color, meaning what? Definitely it is the shallow waters. The waters are not deep waters. This is what the shallow waters. The moment once you go further deep, you can find again the blue color, but this time the blue is intermittent blue, nothing but the medium color blue. And further if you go, the blue is there again, meaning what? The blue color is exclusively given for the water body. This is a dark blue. More the dark color for the more the dark color, more the deep the waters are. That is what the meaning. Is it clear? Might be in your physical map, since you are in one continent, you are not seeing that great depths. If at all you are opening the world map, there you can find somewhat great dark blue colors, light blue colors, further very, very light blue colors. But what blue represents? Blue represents the water body. Sir, my atlas is Oriental Black Swan, sir. So what? Your atlas may be of different company. Every atlas has to give only blue for water. Is it clear? That is about the areas below the mean sea level. Now let us talk about the areas above the mean sea level. Those areas which are close, very close to the mean sea level were given with the dark green color. The areas close to the mean sea level. Don't think that green is called as the plain areas. Not the plain. It is the area which is close to the mean sea level. Normally, the areas which are close to the mean sea level are the plains. Is it clear? What is that green color represents? Wherever you are seeing the green, imagine that all the areas are, almost all, flat and they are close to the mean sea level. They are close to the mean sea level. See the eastern part of Europe? How flat it is? See the Ukraine? Identify the country like Ukraine. Could you see the complete plain area? It's a complete plain area. Are there any mountains in the Ukraine? No. Got the point? Also, come to the India map. Come to the India map. Because you people are well aware of India. When I am talking about the Ukraine, the people are looking at me as if this guy is going every day to Ukraine. Don't look at me. I can understand you are gazing. You come to India. Come to India. See the physical map of India. See the great northern plains. Right from Punjab, Haryana, UP, Bengal, Bihar, Assam. What is the color? Green color. Meaning what? They are close to mean sea level. You see the Bangladesh. Identify Bangladesh. Somewhat more greener than Punjab, Haryana. What do you mean by more green color? More close to sea level. Simple logic. More the darkness of the color, meaning what? More they are close to the mean sea level. That is the reason Bangladesh is very much worrying about the climate change. Because of global warming, what is happening? Temperatures are increasing. When the temperatures are increasing, what is happening? Glaciers are melting. When the glacier melts, what happens to the water level? Rises. When they rise, why Punjab is not worrying? Why Haryana is not worrying? Why Bangladesh is worrying? Because it is more green color. Simply. Got the point? Sir, it's all due to color, sir. As it is more dark green color, meaning what? It is close to the mean sea level. Any rise of 1 meter of water height, it will be submerging the Bangladesh. 1/4 of the Bangladesh will get submerged. Just 1 meter of water. If there is a rise of water level by 1 meter, 1/4 of the Bangladesh will get submerged. Not only the Bangladesh, wherever you are seeing such a dark green color, all those areas get submerged. Is it clear? That is what the areas which are close to the mean sea level. Fine? Now, as and when you are moving away from the mean sea level, slowly the green color which is very dark slowly fades away into light green color, then gives way to yellow color. Gives way for yellow color. What do you mean by yellow color? Nothing but the plateaus, which are located somewhat far away from the mean sea level, but not as far away from the sea level as that of the mountains. These are elevated lands, definitely, but they are not so tall. They are elevated, definitely, but they are not so tall, just like mountains. These are the plateaus. Wherever you can see the yellowish color, identify the plateaus like Malwa Plateau, identify the Chota Nagpur Plateau. You can find all the yellowish color, it's not the green color. Is it clear? Just by seeing the color, you should be in a position to identify whether it is a plateau or the plain or the mountain. When you move further up, it will be given as red color and sometimes even brown color. Red and brown. What do you mean by red and brown? Nothing but very tall peaks. They are far away from the mean sea level. Which landform can be far away from the mean sea level? Mountain. More the dark color, more the tall it is. Now identify where do you find Himalayas. What is the color? Identify Aravalis. What is the color? Identify Western Ghats. Identify Western Ghats. Identify Eastern Ghats. Now come to Europe. Now with this knowledge come to, meaning what? Whenever it is light yellowish color, meaning what? Though it is given as a mountain, its height is less. That is what the meaning, okay? If it is in yellow color, meaning what? Its height is less. That is what you need to understand. Come to the Europe map. Identify the mountains. How to identify mountains are in the Europe map? See the color. Now, whatever the mountains I am mentioning, you please keep on, check this one. The first and foremost one. Pyrenees Mountains. In between Spain and the France. The very important mountain chain called as the Pyrenees Mountains in between Spain and the France. Identify the Pyrenees. Then, after this one, the Dinaric Alps. Dinaric Alps. It is given in an arc-like structure. Dinaric Alps by the side of the Pyrenees. You need to move, keep on moving from east to west. Whatever the name I am giving, you keep on moving. Dinaric Alps. Then Alps. In the France, Switzerland, Austria and all these areas. Alps are there. It is given as A, L, P, S, all capital letters. Alps are there. Then Carpathian Alps. They are called as the Carpathian Alps. Carpathian. Again it is given in arc-like structure, Carpathian Alps. You just move to the western side. From the Alps, you need to move. Are there? Carpathians. Then, the fifth one, couldn't discover. Are not there? There, very good. Then, Caucasus. Caucasus Mountains. In between Black Sea and the Caspian Sea. What is the sea? Blue color body. Identify the blue color water body. In between Caspian Sea and the Black Sea, identify the red color paint. It's called as Caucasus Mountains. Is there Caucasus? The Caucasus Mountains. Now, that is the end of Europe. Come to Asia. Go to the Asia map. All they are the continuous chains. Come to Asia. Mountains of Asia. Yes, page number 66. In some atlases, 66 of some of the atlases. Then also in the older Oxford it is 58. In the Oriental Black Swan. You turn the page. You turn this page. Okay. Yes. 66, right? The page number 66. 58. Around, somewhere around. Okay. Now, identify the mountains that are there in the Turkey. Pontic. PONTIC, Pontic Mountains. PONTAN, Pontine Mountains. Right? Pontic Mountains. Then move to the Iran. Continue towards the Iran in the western side. The mountains are called as Zagros. In the Iran. Don't stick to that area only. Again, don't see the continuity. You need to move further. Zagros. In between there are certain other mountains like Elbrus are there. Don't need to remember all these things. Elbrus, then Anatolia. Don't go to all these minor things. Move ahead. You can find the mountains called as Zagros. Then enter into the Pakistan. Are you entering Pakistan or not? Come on, these fellows are coming every day. At least you enter. You can see the mountain ranges like Kirtar, Sulaiman. The Kirtar and the Sulaiman ranges are there. Kirtar and the Sulaiman ranges. If it is not there, go to the map of India. Go to the physical map of India. The Kirtar ranges and the Sulaiman ranges. Go to the physical map of India. Is there Kirtar? Sulaiman is given? Okay. Sulaiman is given. By the side you can find the Kirtar also. Okay. Then, the ninth one, Himalayas. No need to explain. Right. I should not tell. It is there in the north of something, east of something. All you people are aware. Right. Himalayas. Then go to Myanmar. Enter into the Myanmar. You can find the mountains like Arkanyoma, and Peguyoma. Arkan and the Peguyoma, these are the very important mountain chains of Myanmar. Is it clear? Meaning what? Right from the western part of the Europe till Myanmar, the mountains are almost all a continuous chain. These mountains are put together called as alphinoids, or also called as mid-continental belt. How much percentage of earthquakes and volcanisms are happening? 21% of earthquakes are happening. 21% of earthquakes and volcanisms are happening in this belt. These are the mountains. Have you just stared at the atlas, or you have mentioned all these mountains? Have written all these mountains? All these mountains needs to be mentioned in your class notes. This is the mid-continental belt. In the middle of the continent, there is a series of chain of mountains starting from Spain, Portugal till Myanmar. Is it clear? This is the one. Pyrenees, Dinaric Alps, Carpathian Alps, Caucasus, Pontic, Zagros, Kirtar and Sulaiman, then Himalayas, Arkanyoma and Peguyoma. This is called as Pontic or Pontine, P-O-N-T-I-N. Pontine mountains, but they are also called as Pontic mountains. Why they are Pontic? In the previous textbooks, the old textbooks, all they have mentioned as Pontic mountains. Now they are calling this one as the Pontine. Whether it may be Pontine or Pontic, you write in whatever is given in that list. Like Pontine is given, write down as Pontine. Okay? Pontine, then Zagros, then Kirtar, Sulaiman, Himalayas, and Arkanyoma and Peguyoma of Myanmar. These are all the mountains that are present in the middle part of the continent. stretching all the way from Western Europe till Southeast Asia. What we can see is the mountains are present, volcanism is happening, earthquake is happening, but what we don't know at that point of time was why it is happening there. The people are unaware. Till what time? Till recently, 20th century. The last area, see the last area where you can find the remaining percentage of volcanism and earthquake. This is the third area. The third area is called as African Rift Valley. The African Rift Valley, 11%. The African Rift Valley remaining is 11%. What is African Rift Valley? Come on, go to Africa. When I say go to Africa, you need to pack up your luggage and you need to go. Don't look up, sir, what is this verse? Africa. Go to Africa, and whenever I say any continent, you have to be in the political, not in the political map, in the physical map. Are you there in the physical map of Africa? Now, see the Africa map. You may be seeing the Africa map something like this. Right? This is Africa map. Come to the eastern part of Africa. If you carefully observe the eastern part of Africa, what you can find is there are two parallel lines given like this. There are two parallel lines given in the eastern part of Africa. What do you mean by those two parallel lines? Nothing but this is the area where the land which was united is getting splitted. And it is moving away from this piece of land. In the future, the very Africa will be something like this one. What enters into the middle part? Water enters. Sir, in the future means what? Tomorrow by the same time, sir? Millions, some millions of years. This is what the split that has happened. When the split has happened, what has broken? Rocks. When the rock breaks, what is called as? Earthquake. This is the one. How much percent? 11% of the earthquakes and the volcanisms are happening here in this area. This is called as the East African. These are called as the East African Rift Valley. Is called as the East African Rift Valley. What do you mean by rifting? Getting break and it is separating. You people well aware, na? Oh, please don't rift away. You want, right? You will be telling. That is what the rift, same rift. There is no difference at all. This is what the rift. Got the point? This is the East African Rift Valley. These are the areas where you can find the earthquakes and the volcanisms. This is a distribution of earthquakes and volcanism. Right? In the next class, we'll talk about, since we are completely having the information regarding the seismic waves, we'll discuss about how the seismic waves are giving the information regarding the Earth's interior. In the next class, we discuss about the Earth's interior. Until then, take care. See you. Bye-bye. Jai Hind.